Assalamu alaikum. Welcome to a new chemistry session. Our lesson is chemical equation and reaction, balancing chemical equations. At the end of this video, you will be able to balance a chemical equation, relate the balancing of a chemical equation to the law of conservation of matter. Before watching the video, you should prepare the chemistry worksheet booklet, pen or pencil, draft papers. We learned before that chemical reaction is a process in which starting substances react with each other to produce a new substance or substances. Chemical reaction is made up of reactants and products. Reactants are the starting substances that react with each other, while products are the new substances that formed at the end of the reaction. Chemical reaction can be represented by equation which has the following form, where the terms react with and are replaced by plus, and the term to produce is replaced by arrow. Let's consider the following chemical reaction. Calcium chloride CaCl2 reacts with sodium sulfate Na2SO4 to produce calcium sulfate CaSO4 and sodium chloride NaCl. What are the reactants of this reaction? Calcium chloride and sodium sulfate. What are the products of this reaction? Calcium sulfate and sodium chloride. So, the word equation of this reaction is calcium chloride plus sodium sulfate produce calcium sulfate plus sodium chloride. The chemical equation of this reaction is CaCl2 plus Na2SO4 produce CaSO4 plus NaCl. What happens to the mass during a chemical reaction? Let's refresh our memory from grade 7. If the mass of the reactants in the previous reaction is equal to 300.23 gram, what can you deduce about the mass of the products? In grade 7, you learned that during a chemical reaction, matter is neither created nor destroyed. So, the total mass of the reactants is always equal to the total mass of the products. Referring to this, the mass of the product will be equal to 300.23 gram. This principle is called the law of conservation of mass or Lavoisier law. As long as the total mass of reactants is always equal to the total mass of the products during a chemical reaction. What happens to the number of atoms during this chemical reaction? During chemical reaction, the atoms in the reactants are rearranged to form new compounds. None of the atoms disappear and no new atoms are formed. So, the number of each type of atoms on both sides of the equation will be the same. For this, the chemical equation must be balanced. How do we know that an equation is balanced? How can we make an equation balanced? Before answering these questions, let's remember some terms. Subscript shows how many atoms of an element are in a molecule. Let's take an example. H2O. In H2O molecule, the subscript 2 shows that we have 2 atoms of hydrogen, and the subscript 1 shows that we have 1 atom of oxygen. Usually, the subscript outside the bracket multiplies all the atoms inside the bracket. Example, Ca2PO4 3. The subscript 2 shows that we have 2 atoms of calcium, and the subscript 3 is outside the bracket, so it should be multiplied by the atoms inside the bracket, which are phosphorus and oxygen. 3 times 1 equal to 3, so 3 atoms of phosphorus. 3 times 4 equal to 12, 12 atoms of oxygen. Coefficient shows how many molecules or atoms there are of a particular chemical. Let's take some examples. 3H2O. The coefficient 3 means that we have 3 molecules of water. 2C. The coefficient 2 shows that we have 2 atoms of carbon. 2N2. This is the coefficient and this is the subscript. In this case, the coefficient should be multiplied by the subscript. 2 times 2 equals 4. So we have 4 atoms of nitrogen. 4SO4. This is the coefficient. 4 times 1 equals to 4. So we have 4 atoms of sulfur. 4 times 4 is equal to 16. So 16 atoms of oxygen. Now, open your booklet in worksheet 17, read the introduction, then let's solve together the applications. Application A. Consider the chemical equation H2 plus O2 produce H2O2. Is the chemical equation balanced or not? To answer this question, we should start by counting the number of each type of atoms on both sides of the equation. To make this step more easier, draw a table that shows these numbers. Now, let's start counting. According to the above equation, we have 2 hydrogen atoms in the reactant and 2 hydrogen atoms in the product. 2 oxygen atoms in the reactant and 2 oxygen atoms in the product. By comparing the two sides, you can observe that we have the same number of hydrogen atoms in the reactants and the product and the same number of oxygen atoms in the reactant and the product. So, the same number of each type of atoms on both sides of the equation. This means that this chemical equation is balanced. Question number 2. Represent this chemical equation by drawing the molecular models using the white ball for the hydrogen atom and the red one for the oxygen atom. H2 means 2 hydrogen atoms plus O2, which means 2 oxygen atoms, produce H2O2, 2 hydrogen atoms and 2 oxygen atoms. Question 3. What do you conclude about the atoms during a chemical reaction? According to the above molecular model, you can observe that we have the same number of hydrogen and oxygen atoms on both sides of the equation. So, during a chemical reaction, the number of each type of atoms must be equal on both sides of the equation, which means that the number of atoms of each element is conserved. Question 4. The mass of H2O2 produced is 68 grams and that of O2 reacted is 64 grams. Deduce the mass of H2 reacted. According to Lavoisier's law, the mass is neither created nor destroyed in a chemical reaction. So the total mass of the reactants is equal to the total mass of the products. The reactants of this reaction are H2 and O2, while the product is H2O2. So, mass of H2 plus mass O2 is equal to the mass of H2O2. In this question, we need to calculate the mass of H2 reacted. So, mass of H2 is equal to mass of H2O2 minus mass of O2. The mass of H2O2 is 68 grams, and the mass of O2 reacted is 64 grams. 68 minus 64 equal to 4 grams. Now, pause the video to solve applications B. Consider the chemical equation H2O decomposes into H2 plus O2 in the presence of electricity. Construct and draw the molecular model of the reactant and the product using the following symbols. In H2O, 2 hydrogen atoms and 1 oxygen atom decomposes in the presence of electricity into H2 plus O2. Question 2, Part A. Count the number of atoms in both sides of the equation, then fill in the following table. According to the equation, we have 2 hydrogen atoms in the reactant and 2 hydrogen atoms in the product, 1 oxygen atom in the reactant and 2 oxygen atoms in the product. Is this equation balanced or not? By comparing the two sides of the equation, we can observe that the number of hydrogen atoms in both sides of the equation is equal, while the number of oxygen atoms on both sides of the equation is not equal. So, the number of each type of atoms on both sides of the equation is not equal. This means that this chemical equation is not balanced. Now, let's go step by step to see how to balance this equation. After counting the number of each type of atoms on both sides of the equation, it's always a good idea to draw boxes around each element or compound. To remember that nothing inside these boxes can be changed, including the subscript. Also, you can add lines for the added coefficient. This row in the table shows that the number of oxygen atoms is not equal. So, by adding coefficient 2 in front of H2O, the number of oxygen atoms in the reactant will change to become 2. Also, the number of hydrogen atoms in the reactant will change to become 4. To balance the number of oxygen atoms in this equation, you cannot change H2O into H2O2, since the subscript cannot ever be changed. Now let's move to balance the number of hydrogen atoms in this equation. By adding coefficient 2 in front of H2, the number of hydrogen atoms in the product will change into 4. By comparing the two sides, we can observe that we have the same number of each type of atoms on both sides of the equation. So this chemical equation is balanced. The balanced equation of decomposition of water is 2H2O decomposes into 2H2 plus O2. Steps to balance a chemical equation. First, you should count the number of atoms on both sides of the equation. Second, never change the subscript. Third, put a coefficient in front of the chemical formula so that the number of each type of atom is the same on both sides of the equation. Remember that the coefficient added must be natural number, and the coefficient must be the least common multiple LCM. The last step, that the number of atoms of each type is computed by multiplying the coefficient by the subscript. Example, 2 and 2. 2 times 2 equal to 4. So, in this case, we have 4 atoms of nitrogen. Now, let's solve some applications. Application 1. Na plus Cl2 produce NaCl. Is this equation balanced? Pause the video to solve the application alone, then follow me. Let's start to draw the molecular model of each one. By counting the number of each type of atoms on both sides of the equation, we obtain 1 sodium atom in the reactant and the product, 2 chlorine atoms in the reactant, and 1 in the product. By comparing the two sides, we observe that we have the same number of sodium atoms, but different number of chlorine atoms. So this chemical equation is not balanced. How to balance this equation? Let's see. To balance the number of chlorine atoms in this equation, you can start by adding coefficient 2 in front of NaCl, so that the number of chlorine atoms in the product will change into 2. Also, the number of sodium atoms in the product will change into 2. To balance the number of sodium atoms, you can add coefficient 2 in front of Na, so that the number of sodium atoms in the reactant will change into 2. The balanced equation will be 2Na plus Cl2 produce 2NaCl. Now, application 2. CH4 plus O2 produce CO2 plus H2O. Is this equation balanced? Pause the video to solve the application alone, then follow me. After counting the number of each type of atoms, we obtain 1 carbon atom in the reactant and the product, 4 hydrogen atoms in the reactant and 2 in the product, 2 oxygen atoms in the reactant, and 3 in the product. By comparing the two sides, we observe that we have the same number of carbon atoms and different number of hydrogen and oxygen atoms. So the number of each type of atoms on both sides of the equation is not equal, which means that this chemical equation is not balanced. Let's now move to balance this equation. To balance the number of hydrogen atoms, you can start by adding coefficient 2 in front of H2O, so that the number of hydrogen atom in the product will change into 4. Not only this, also the number of oxygen atoms in the product will change into 4. To balance the number of oxygen atoms in the reactant, you can start by adding coefficient 2 in front of O2, so that the number of oxygen atoms in the reactant will change into 4. By comparing the two sides, we obtain the same number of each type of atoms in both sides of the equation. So the balanced equation will be CH4 plus 2O2 produce CO2 plus 2H2O. Application 3. Indicate whether the following equation is balanced or not. Zn plus H2SO4 produce ZnSO4 plus H2. Pause the video to solve the application alone, then follow me. By counting the number of each type of atoms in this equation, we obtain 1 zinc atom in the reactant and the product, 2 hydrogen atoms in the reactant and the product, 1 sulfur atom in the reactant and the product, and 4 oxygen atoms in the reactant and the product. By comparing the two sides, we obtain that we have the same number of each type of atoms on both sides of the equation, which means that this chemical equation is balanced. Application 4. C2H6 plus O2 produce CO2 plus H2O. Is this equation balanced? By counting the number of each type of atoms on both sides of the equation, we obtain 2 carbon atoms in the reactant and 1 in the product, 6 hydrogen atoms in the reactant and 2 in the product, 2 oxygen atoms in the reactant and 3 in the product. By comparing the two sides of the equation, we observe that we have different number of each type of atoms. So this chemical equation is not balanced. To balance this equation, you can start by balancing the number of carbon atoms by adding coefficient 2 in front of CO2, so that the number of carbon atoms in the product will change into 2. Also, the number of oxygen atoms in the product will change into 5. To balance the number of hydrogen atoms, you can add coefficient 3 in front of H2O, so that the number of hydrogen atoms in the product will change into 6. Also, the number of oxygen atoms in the product will change again to become 7. To balance the number of oxygen atoms, you can add coefficient 7 over 2 in front of O2. So 7 over 2 times 2 equal to 7. But pay attention, the coefficient must be natural number, since there is no parts of atoms or molecules. So what you have to do in this case, you should multiply the equation by 2, so the balanced equation will be 2C2H6 plus 7O2 produce 4CO2 plus 6H2O. As a summary, during a chemical reaction, total mass of the reactants is equal to the total mass of the products. The number of atoms in the reactants also equal to the number of atoms on the products. For this, the chemical equation must be balanced. To balance a chemical equation, step 1, count. Count the number of atoms of each element on both the reactants and the products. Step 2, determine. Determine which atoms are not balanced. Step 3, add. Add the appreciate coefficients to balance the number of atoms of each element. Remember, you cannot never change the subscript.